All right, the final type of plot that we're going to discuss is the forest plot. So here's an example of a forest plot. And here we're looking at many variables. And these variables can be of any type. They can be continuous or categorical. And the main purpose of a forest plot is to compare many different effects. And so the most common use of a forest plot is in a meta-analysis. So remember from way back when we were talking about study design, in that section we were talking about how a meta-analysis attempts to combine the observed effects from multiple studies. So for example, here I have a forest plot that displays effects from 4 studies, study A through study D. And these circles here correspond to the point estimate from each study. And then the line corresponds to the uncertainty that's associated with each given point estimate. So this is often the 95% confidence interval. And this dashed line, which I've overlaid with a green dashed line, that shows the null effect or the no effect line. And so generally, when the confidence interval crosses this line, it usually means that a statistically significant effect was not detected. So many times a forest plot not only displays effects with the purpose of comparison, but it can also show a summary of those effects. And that's very common in meta-analyses. And so for that, usually a diamond is drawn at the bottom. And in the case of a meta-analysis, this diamond attempts to show that overall consensus in the literature for the effect that's being evaluated. So similar to the scatter plot, the main potential pitfall for a forest plot is going to be the scale. And so this is, again, what we were looking at in that very first section when we were talking about how statistical graphics need to be properly scaled. But for example, if here I'm trying to compare these 2 points, when I add an x-axis, we can see that the range is from 94 to 100. But suppose that a meaningful range for this data was actually 0 to 100. The original plot made it look like there was some real difference between these 2 effects, and it made that difference look pretty large, between these 2 effects. But when we actually properly scaled it, we could see that those 2 effects are actually quite similar. So here's an example from the literature, and you can find this study in PLOS One. So here we're looking at a meta-analysis examining hypertension and the risk of cataract. Notice that the forest plot here has the study names on the left with the corresponding effects and the confidence intervals on the right. So that's typically how you're going to see these. And here, that null is displayed using a black line right at 1. And the summary value is displayed with that diamond as well as a dashed red line. So taking a look at this plot, we can glean that, we can interpret that the pooled results of 14 studies shows that the risk of any type of cataract was significantly higher in patients with hypertension.